Hey guys, example 1 here, and I encourage you to watch example 0 because there I talk about the idea behind implicit differentiation. So you'll get a lot out of that video and it will complete your understanding. But here in this video, I'm just going to show you how a first basic example works. And so we do implicit differentiation when we've got a function that's defined implicitly. So like the function has like x's and y's multiplied and x's and y's on the same side, and even the y terms are squared, like y squared or cubed and so on, as you'll see in other examples to come. But yeah, you have that going on. And of course you have an equal sign, and the right side might be just a constant like this one on an easier example, but it might also be like a lot of complicated mess, just like the left side, right? So it might have like variables on both sides of the equation is what I'm saying. All right, in any case, if you're trying to do well on your test, this is all you got to remember, really. If you take the derivative of something involving x, then you take the derivative as usual. And if you take the derivative of something involving y, as soon as you take the derivative, so for y squared, the derivative would be 2y as usual. But as soon as you take the derivative, so as soon as you write 2y, you must remember to multiply by dy dx. So basically, for stuff that just involves an x, right? X squared, x cubed, and x cubed multiplied by a constant or whatever. Stuff just involving x, then you take the derivative as usual, and that's it. But for stuff involving y, you take the derivative as usual, pretending like the y is like an x, but you also now have to multiply by the derivative of y, which is dy dx, right? And that's because of chain rule, and I talk about these details in example 1 and example 0, so check that out. Hey guys, example 1 here, and I encourage you to watch example 0 because there I talk about the idea behind implicit differentiation. So it will add a lot to your knowledge and it will complete your understanding. But in this video, I'm just going to give you a typical first example. And that'd be like, finding dy dx on an implicitly defined function like this one. Now, if you're trying to do well in your test, and that's your only goal, then you don't need to watch example 0. That's for nerds like me who like to know how stuff works. But yeah, so for those of you that are just trying to pass a test, this is all you have to remember, which is if you're taking the derivative of something involving just x, like x squared, then you take the derivative as usual, and that's it. So for x squared, we'll write 2x, and that's it. But when you take the derivative of something involving y, you take the derivative as usual, so we write 2y, but then immediately upon writing 2y, we have to also multiply by dy dx. So every time you take the derivative of something that has a y in it, you must remember to take the derivative as usual and then multiply by dy dx. Okay, so let's get on with it then. The derivative of this guy is 2x. And then in the middle here, we encounter the product rule because we have x times y. And remember, the product rule said that if you have f times g, then the derivative of f times g, the product of f and g, is equal to f prime times g, and then plus f times g prime, right? Quick reminder. So I took the derivative of this, I wrote 2x, and then I have plus, and now applying the product rule here, where f is x and y is g, we'll have to say f prime, so the derivative of x, and that's just 1, times g, so times y, and then plus f, which is x, times the derivative of g, and since g is y, the derivative of y is going to be 1 times dy dx, and so just dy dx. And this is what I'm talking about. We just took the derivative of something involving y, and technically I should write 1 in front of the dy dx, but why bother? But yeah, after taking the derivative of this term, this guy here involving y, now I have to multiply by dy dx. And so that's what I reminded you of earlier. Now we're done with the product rule because we have f prime times g plus f times g prime, and g prime, as I said, is technically 1 times dy dx. But yeah, we're done with the product rule clearly. All right, so moving on, I've got this plus sign and there. And now I take the derivative of this guy, which is 2y. But wait, since this involves y, I have to multiply by dy dx. Yeah? Okay, cool. Equals, and now the derivative of the constant 7 is 0. Okay, cool. This is a typical place to be after you find the derivative of everything in your equation, which is you'll have some stuff that's multiplied by dy dx and some stuff that's not. And since the goal is to solve for dy dx, you want to get the terms involving dy dx just on one side of the equation. So to do that, it's clear that what we have to do is subtract 2x from both sides of the equation in white, right? And then also subtract a y, right? Okay, there we are. And now this will mean that on the left side, all this is gone. And on the right side, it's kind of silly to write 0 minus 2x minus y, so I'll just write minus 2x minus y. All right, so let's do that. Right? Okay, now here on the left side, it's clear that we can factor out a dy dx, and we'd like to do that since ultimately we're trying to solve for dy dx. Right? So dy dx, and then times, and then it'll be x plus 2y, right? Okay, and the right side will be minus 2x minus y. Okay, cool. And now, dividing both the left side and the right side by x plus 2y, we can get dy dx all by itself as desired. So this guy and this guy cancel, or they just turn to 1. So we see that dy dx, I don't like that. Sorry guys. We see that dy dx, that's better, is equal to negative 2x minus y all divided by x plus 2y. Yeah? Okay, cool. All right, example 2 to come, and as I said, they'll get more and more challenging, so keep watching. Take care.